Hi, it's Miss Chapman. Sorry I couldn't be there. I had a meeting at the Ausland Mujeres, so I'm filming this on Sunday, and we are doing 1.4 Financial Applications Part 2. So it's still going with the same worksheet you had. However, I want you to start taking notes on paper. So you can use an just paper in your heft, or you can use a spiral or bound notebook, but somewhere where you're going to take your math notes from right now. And you can take these notes and then underneath it, you can write the homework problems out on paper. And that way you have as much paper as you need to write. If you write big, small, however you want to write. It is a lot of writing, but it is going to help you learn. So the first thing you're going to do is label this section in your notes 1.4 financial applications, and we will get started. And then I want to take you to the formula for compound interest. So this is the SLIB um, formula book out. So if we scroll down to, this is the standard level, but the HL has the same formula. So if we scroll down to 1.4, you can see the formula that I'm supposed to be teaching you. So this is the compound interest formula. Before we had simple interest, and this is if it compounds, if it gains interest at different times. So if you can first just copy this formula down and what each of the values mean. So we have the future value is the present value times 1 plus the rate, and this rate will be in a percentage. And don't worry, I'm going to show you tons of examples. We're just copying it down. Divided by 100 times K, where K is the number of compounding periods per year. So if you take out a loan for a house or a car or a credit card or whatever interest bounding thing, or you're investing money, uh, they compound the interest at different times. So they could calculate interest daily, monthly, yearly, 4 times a year. It just depends on the terms of the loan. And then we need the number of years. So maybe they compound once a year for 5 years, maybe 4 times a year for 10 years, all of that. So all that's going to affect how much money you have and how much interest you pay. So this is the formula we're going to look at. Go ahead and copy this down and pause this video. And once you have it copied in your notes, I will teach you how to use it. Okay, so you should have copied that in your notes by now. And let me share the screen, and also let me make it to the side of me because otherwise nobody can see me. Um, I'm still learning it. I might be old, but I've got this. Okay, here we go. Yeah. So we did the formula chart. Okay, so this is the second half of the paper that I gave you last time, but I do want you writing in your own notes section. So I would not copy down this problem. I'll read you the problem and I will show you what I would write as a student. So it says a loan of 12,000 Malaysian ringgit. I apologize if I'm saying that long. It's their unit of money. Accrues 3.2% compound interest annually. So that's yearly for 4 years. What is the total repayment amount? So we want to know how much are we paying back. And in my notes, what I would first write down is the compound interest formula. So I'd write example one, and then I would write down the formula. So my formula is the future value is equal to the present value plus one. Oops, let's actually write this equals the present value times, I'm going to use the dot, 1 plus the rate over 100K. And all of that is to the power of K times N. And we're not afraid, we're just taking it one step at a time. So you're just copying that down. Okay, the next thing I would do as a student is write down the values, and you can go faster than this. I'm just showing you every step that I would do. So the future value is what we want. What is the total repayment amount? That is the future value. So I'm going to put future value equals question mark. Okay, the present value is going to be 12,000 Malaysian units of currency. Don't know how to say that. And then the next letter I see is R. So my rate is 3.2%. And they want it as a percent for this formula. There's another formula that doesn't take a percent. We're not learning that one today. So I'm just going to teach you what you need to know for this formula. Okay, then they want to know K. So K is the number of compounding periods. And for this, it's just annually. And if this is a lot for you, you're going to see many, many examples. Give yourself a chance to get it. So annually means once a year. Biannual would be twice a year. Maybe they tell you 12 times a year or every monthly. But annually is just once a year. So K is one. And then the number of years is 4 years. So here N means number of years. Awesome. And remember, you'll get that formula chart that has out what these things mean, but we do need to be familiar with it. So this is what I would have in my notes. The next thing I want to do is actually plug in and solve for these values. So I'm going to go ahead and plug into this formula. And I have the future value. Oh, and let me move this little icon for Zoom that you can't see, but I can see. It's blocking me from writing. The future value is going to be equal to the present value. So I'm going to plug in 12,000 times 1, and you can see I'm just following this formula here. I think you can see my pen, I'm not really sure. Plus the rate, 3.2 over 100 times 1. You don't really have to write times 1, but I'm writing it to be extra. And all of that is to the 1 times 4 power. So we're going to go ahead and enter this in our calculator. Make sure you have this down. You can pause it here if you don't have it down. And we should get in our calculator, and I will show you the calculator in just a second, but it'll delete this when I switch between. I still haven't found the right software to make it do that. But we should get 13,611.31 Malaysian ringgit, which is abbreviated RM. And you do have to write out the unit. You can copy the whole unit or the symbol if this was on an IB test. So there's the thing. And let me show you how to put that in your calculator. So I'm going to share my calculator. Here we go. So here's the calculator, and I'm going to go through all the steps of entering that. Feel free to go through this faster. So the first thing I'm doing is going to this run matrix. That's the math, and I'm going to plug it in. So I've got 12,000 times 1 plus, and we have to be really, really careful in order of operations here. I'm actually going to put this fraction in a parentheses, 3.2 divided by 100. So in red is 3.2 100ths. And then I want to close that. And outside of the blue parentheses, I'm going to put 4. So the first time I did this, when I was like prepping for this video, I accidentally put the 4 in the parentheses. So be really careful. And there we get our answer. I'm rounding to 2 decimal places. And the next topic, 2 topics or so, is rounding. But I'm rounding to 2 decimal places since currency is rounded to 2 decimal places. And 3 is less than 5. So I'm going to leave it at 0.31 as my final answer. And that's how I did that. Okay, let's do another example. I might go a little bit faster for this one, but you can rewatch the video if you need to. And there we go. So I'm going to do example 3 on the note sheet. And it says a deposit of 20,000 Brazilian real is made into a long-term savings account that offers 5.5% annual interest compounded quarterly, so 4 times a year. How much will be in the account after 4 years? This one's a little bit different because our K value is no longer 1. So again, I'm writing my formula. Present value times 1 plus R over 100K, all of that to the Kn. And we can plug in all of the values. So you can list out the values like I did before. That's actually my favorite way to prep problems, but I wanted to show you another way. You can actually just write them up here. So some students will write, okay, R is here in the problem. Quarterly means K equals 4, R equals 5.5. The deposit is the present value, and we want how much will be in the account after 4 years. That is the future value. Yep. So now we can plug in. So this is another way you could do the problem. I probably wouldn't do this. I would list them out, but here you go. Okay, so for this one, we want the future value. It is our present value, in this case, 20,000 Brazilian real. That's probably not how you say that. And I'm going to multiply that by 1 plus 5.5% interest over 100 times K. So again, K here is compounded quarterly. K is the compound periods. I'm gonna keep saying that because it's really confusing. Financial math is not easy, but we've got this. So it's gonna be 4 because that's the compounding periods. K compound, spelled different in English, but it has the same sound. And then I need 4 times how many years? 6 years. So does this make sense that if you're compounding quarterly for 6 years, it's actually 12, 4 times 6 compounding periods. So it's similar to that simple interest, but instead of just having the number of years, there's actually 12 compounding periods because they're doing it 4 times a year for 6 years. So again, now we can just put this in our calculator. I shouldn't say just put this in in our calculator because it's quite confusing. If you put this in your calculator, I would suggest here either just typing 12 or putting 4 times 6 in parentheses. I would also suggest here just typing 400 or putting more parentheses. If you make a lot of calculator mistakes, you're going to want to try and enter it 2 different ways in the calculator. The only way to get good at calculators is to use them over and over again. I really wish there was a different way, and some people just have the gift. So you should get 20,756.89 Brazilian real, which looks like it's R and then the dollar sign with 1 line through it for our symbol. All right, so that was your second example. Get ready. I have one more solving for a different variable, and then one more when you have to solve for an exponent, which we haven't learned. So I will show you how to do that in the calculator. Okay, the next example is going to be 5. And I want to know investment grew to 3,520,000 South Korean won after 4 years with interest compounding annually at a rate of 6%. Here we want to know what was the initial amount. So let me kind of write out what we know. So we actually, in this case, know that the future amount is 3,520,000 won. And we want to know what the initial amount was. So in this case, it would be the present value. Let's see, what else do we have here? We know that R is 6%. And we know that K is compounded annually, so once a year for 4 years. So the last one was compounded multiple times per year. This is just compounded periods once for 4. So let's plug that in. Trying to switch colors here. So with my whole formula, I'm copying the formula again. You don't have to, although I do think it's funny when students don't write as much as me and I'm the math teacher and then they don't get it. I just writing more, it helps your brain process. This video is already too long though. K times N. Okay, so I'm going to plug in 3,520,000, 1, 2, 3, and let me just put my commas so I don't make a mistake here. I want to know the present value. I don't like when variables are 2 letters, but this is one variable. And I'm going to plug in the rate. K is 1. Again, you don't have to write times 1 since any number times 1 is itself, but I'm just doing it to reduce confusion since I'm not there to answer that question. Okay, so to put this in my calculator, I am actually going to first reduce the left side of the equation. So you should have your calculator with you. And I'm actually going to type this into my calculator right here. Okay, that was an awful sound. I hope you did not hear that. I'm typing it and you're typing it as well. And you can fast forward if you really just don't want to watch me put something in a calculator. Okay, so I'm typing 1 plus open parentheses, use lots of parentheses. And again, you're only going to get good at using all these parentheses if you actually do it. Divided by So for this value here, I got an awful number, which you don't need to write. You can just leave it in your calculator. Then I'm going to divide each side by said awful number. And I just did this in one giant step in my calculator. So whatever we do to one side of the equation, we have to do to the other. These cancel out. Remember, there's not really a math operation called cancel. It's just anything divided by itself in one. And I get that PV is equal to 2788169 point. Oh, this interesting rounding because it's gonna round up. Uh, our dollar sign. There we go. Okay, so there's my total amount. And again, I didn't actually write this whole amount down. I just did divided by second answer in my calculator. Okay, so the next thing I want to do is one that you can't really solve yet. And this is the last example like this on your paper. So it's 7, and you're going to do the other ones for homework. So this one said a loan increased from 17,952 euros and 22 cents after being compounded monthly, so 12 times a year. And let me write that up there just so you start thinking this way. Monthly means that K, the compound periods, are 12 times per year at a rate of 4.5% for a number of years. If the original loan was 15,000 euros, how long was the loan term in years? So let's write out what we know. We know that the future value ended up being 17,952 euros with 22 cents. And we know that the original value, the present value doesn't really make sense, but the principal value here, the original amount was 15,000 euros originally. We know that the rate was 4.5%. We know that the compounding periods were 12 because it was monthly, so 12 per year. And the number of years is unknown to us. We're about to solve for it. So something interesting is going to happen when we plug this into the equation. Interesting for me, at least. When I plug it into our equation. Okay, so equals, let me move the zoom icon. The rate divided by 100 times 12. And all of that is going to be to the 12n. So n here means number of years. N in your calculator doesn't always mean that. So you really have to know what you're talking about. It's not enough just to plug into formulas and not know what's happening. You really have to know. It requires you to think. So try to engage in this as much as possible. So you actually don't know how to solve for an exponent yet. We're learning that this week how to do logarithms and solve for exponents, but you don't know. And so you can't simplify this algebraically. My preference to solve would be using algebra and rearrange this. However, we currently cannot do that. So I am going to show you how to do this in the calculator. You can solve for any of these variables in the calculator. I think the calculator is more work than it is worth, but here we go. So things to know how to solve this in the calculator. Okay, so in your Casio, and I think everyone here has the Casio, not the TI, you are going to have to go to financial math, and here's what everything in there stands for. So I would copy down solving in calculator and copy down these things, and then I'm going to show you this problem in a calculator. So n is still the number of compounding n is now the number of compounding periods, meaning years times compounding periods, and that's a little confusing. Everything else is almost the same. So I is still the interest rate as a percentage. The present value is going to be negative in our calculator, so that's something new. The payment periods, we don't have payment periods. The calculator is designed to solve for more complex things than we're solving for, so we don't have that. We're going to leave it 0. The future value is still the same future value. The payments per year is also going to be 0 because we're not doing anything with payments. The number of compounding periods per year is exactly that. And this we're going to leave on n because again, we don't have a payment. And then we're going to solve for a variable. So that's a lot of information that you can copy down. And then let me actually do this problem with you. So I'm sharing my calculator. We're solving the same problem that you just did in your notes, but we could not solve for the exponent. No Zoom, share my calculator. There we go. Okay, so here's my calculator, and can I make this bigger so that I can write on it? I think so, yeah. All right. So the first thing we need to do is go to the financial stuff in our calculator. So I'm going to click on menu, and I want this financial thing here. So let me go there, execute. All right. Simple interest is what we did last week. I want compound interest, and it says F2, so you have to push F2. And here we're going to plug in our values and solve. So I'm going to recopy them, but in the calculator way, since they're a little bit different. So what we want to know is what is n. However, unfortunately, the number of years in n in the calculator means something slightly different than n in the formula from IB. I didn't make the calculator, I didn't make the IB formula, but we're going to learn how to use it. So I think it's clear that we want to know n so far, but we'll get to the confusing part in a minute. So interest is, for I, I'm going to plug in 4.5. For present value, I'm going to plug in negative 1500 because the way the calculator is thinking, it's thinking more like the way an actual banker would use it, is that if you're investing 15 or you're taking out a loan for 15, 15 is going away. You don't have that money, so it's negative. The payment amount, we do not have a payment amount. I mean, of course, a real loan would have a payment amount, but we're not doing that math yet. The future value for this problem was 17,952. The payments per year for this situation was 12. There were 12 payments per year. Sorry, compounding periods for year, compounding periods for year. And move this is 12. Okay, so let's put this in the calculator and I'll show you how to solve it. And I think I have one more example after this that I put too, because I do think it's quite confusing. Okay, I think I did 2 more examples. How much did I write? Oh my gosh. Okay, so we want to know n. I'm not going to put anything there. And let me get rid of my pen. And then for the interest rate, go down, calculator is 4.5. The present value is minus, enter. The payment we're leaving, the future value is going to be 17. And then these are 12. So 12 payments per year and 12 compounding periods per year. Yeah, I've got too many screens open. Okay, so we want to solve for n. So I am going to click on n is here for F1. So I'm going to click on F1 and it tells me 48. So this is not 48 years. This is 48 compounding periods. Let me write that out in a different color. I'm so sorry. I promise you watch these YouTubers and that's just not me. So the calculator told us that n is 48. That's 48 compounding periods. And this is why I told you I like algebra better than the calculator because you have to think anyway with the calculator. So if there are 48 compounding periods, and there's 12 periods per year, then there are 4 years. So our final answer is 4 years. And I could have, in way less time, used logs. Maybe this is a good preview for why we need to learn logarithms in the next week, because I could have done that way easier with algebra and gotten 4. But there you have it. There it is. So I'm going to do one more example. If you want, you can stop watching here, but if you want one more example of how to do this in the calculator, I shall show you that right now. Um, where is my slideshow? There is my slideshow. Yep. Okay. So I have another example here, and this is a deposit of 12,500 pounds, earns 4.8 percentage per year for 5 years. We want to find the future value of this investment. So I'm going to go a little bit faster, but just show you how this could actually go really fast in your calculator. Okay, so for this one, it's compounded once per year for 5 years. So n in our calculator is five. Um, I'm doing two examples. This is the first one. N in our calculator is five. The percentage is going to be the interest rate in our calculator. They use I like this is 4.8. The present value in our calculator, and again, you could do the formula if you really hate this calculator thing. Um, the present value is 2,500 because again, your calculator is thinking like a banker and you gave away that money, so it's negative. But you can just remember for this calculator that it's always negative. That's what I do. There's no payment amount here given to us. The future value is what we want to know in our calculator. Payments per year are one. Um, And again, it's not you paying, it's the bank paying interest here, which is quite confusing, I think. And it's compounded once per year. And I think that's it. So we want to find our future value in the calculator using these amounts. So I have to switch to the calculator view for you, and we'll put that in the calculator, and it might be a bit easier for you. Okay, so let me go back to here. And it has my old data, but that's fine. We'll just write over it. So now this is going to be for execute. My interest rate is 4.8 for this problem. Execute. I invested 2,500, or this person did pounds. The payment amount is zero, which is kind of weird, but that's what we're doing. The future value is what I want to know. So let me just change that to zero for now. And the payments per year are one. And it is also compounded once a year. Perfect. So I actually want to know future value. If you look down here, I'm going to click F2 for future value, and I get the future value. Wait, did I type everything right? 4.8. N is 5. Oh, N is 5. There we go. It's like it's a little bit off from what I got. There we go. N is 5 from the problem. 4.8. Yes. Now I can compound the future value. Again, I still think this is more trouble than it's worth. There we go. So our final answer for this problem is 3,160 pounds and 43 cents. I'm not actually even sure if it's cents. And this was British pounds for our final answer. And I'm going to do one more in the calculator. If you really, really like the calculator, again, you don't have to keep watching, but it could be useful. So the final example, there's no more slides, I promise. We have a sum of 50,000 Chinese yen invested at 4% annual interest, and it is compounded monthly for 3 years. We want to find the total amount at the end of the term. So in your calculator, I'd write example 2 and list out all the things we have here. So in our calculator is going to be the total number of times that interest is calculated. So if it is calculated for 3 years monthly, it's calculated 36 times. In the formula from the IB, it has you multiply these two as K and N. So it uses this monthly as K, and this is N in the formula from IB. But in your calculator, it just combines both of those in one. And there's different ways of writing the formula, and I'm so sorry that it's two different ways for you. The interest here is 4%, which is what I misread last time. The principal value or the present value is negative because you're investing this money. It is going away. Again, in the IB formula, it's positive, but in the calculator's thinking like a banker, it's negative. The IB is more math and the calculator is more like application. So that can be a little bit tricky. Payments per year are 12 because it's every month and that's compounded monthly. So compound per year is also 12, and we're going to solve for the future value. So what I wrote in blue is what I would write on my paper for this example. Okay, let's do it in the calculator. Again, feel free to do this in the formula thing. It's just how you do it. Okay, so for this one, we said n was 36 because it's 12 times 3 is 36. The interest is only 4% here. The original amount was 50,000 yen. No payment size. I mean, here the payment would be like if they add money to it, but that's not a thing. The future value we don't know. But this is going to be 12. There's 12 payments per year, and it automatically does both. So I need to go up because I want to find this future value. It's not in fact zero. Future value is above F5, so I'm pushing S5, and it actually tells me the correct future value. So the correct future value is 56,363.59 yen, the two little things. That's our total amount. Okay, that is the end of these notes. So for your homework, you are actually finishing the rest of that page, and I will post it on ManageBack for you.